turns. 200 lines I should draw. I'm just showing only few. So initially, so this will be the some equilibrium position, and here is what? The weight. The length of the right arm of the balance is L. How the B bar should be from north to south pole, no? So here we are going to get a magnetic field vector. I'm showing by dotted lines. So this, what is this green color one? So these are the magnetic field vector. No. So this is the okay, come for this. So this is the B bar. Will there be any dipole moment? How the current should flow? Any direction of current? So let me put direction of current like this here. And this cylinder is attached to the rod. There's a rod. So how the M bar due to this coil will be in this direction. And B bar is like this. So torque due to dipole moment will try to rotate the system, this rod in anti-clockwise in this sense, or towards right. So B bar is here, no? So don't look at upper arrows, look at the down arrows. Our torque due to dipole moment will be in this sense. So about O, so depend the torque due to this should be in this sense, no? And due to this weight, it will be in this sense. So is it suggestion? Is it direction of current? Is it suggestible like this? So I'll just put in this direction. So then the M bar will change. It will come like this. Now M bar cross B bar, check it, no? So how that will be anti-clockwise about O. But sir, like a loop is here, the point, the hinge is here. How do this will be? The overall loop, what will be connected to rod, no? What torque that is acting on this loop and this particular coils are owned on a cylinder, and the cylinder is connected to a rod. So what torque is acting on the loop, that torque will be acting on the cylinder, and what torque is acting on cylinder, that torque will be acting on the rod. I think you have to make the mechanism like this here. So let's take the M, this one. So here the weight mg will act. So we will balance torque due to dipole moment should be mg into L. What is the torque due to dipole moment? M B sine 90. So what is M? I into number of turns N, I into S. The IT has given area of cross section. Find the magnetic induction field in terms of that one. So here B is there, no? Yeah. B equal to mgl by NIS. So different types of systems will come. So you should be very specific. Application of dipole moment. Now, what is the advantage of increasing number of turns? We'll get more dipole moment. And all those turns, the spacing, this gap will not be very large. The number of turns, usually what happens within 0. Around 2 centimeters, 0.2 centimeter, I can wound around more than 100 turns. So when say ring and coil, there's a difference between ring and coil. If you say ring, no, only 1 turn. When I say coil, circular coil, so what you should assume that within this gap, there are some 100 turns, 200 turns, 300 turns like this. And what will be this width? You have to take negligible. And what is the radius of the coil? R and N. So it can be 100 turns. Coil, circular coil of 100 turns and radius R. Sir, but how come practically this one? The turns are wound so close that this width will be negligible compared to R. So if you take this X, no, X will be of order 0.1 centimeter. R will be of order say 30 or 20 centimeter. So then almost all the turns are at a distance R only. Fine. So you try to manage this difference between the ring and the coil. So what is the advantage of bringing the coil? If dipole moment, here how much dipole moment will be? M equal to I into pi r square. What about dipole moment here? N into I pi r square. So what will happen to the dipole moment? Will increase by n times, no? So more number of turns, more that will be. So the dipole moment will increase by 100 times here. So that's why, so always we'll go for a coil. The coil can be of any shape. Even I can go for rectangular shape also. Again, the dimensions of coils will be such that the spacing between the turns or say, this particular distance will be negligible compared to this one. Okay, this one's rectangular coil, circular coil, triangular coil. These are the different things will come for this question. Read the question. The magnetic field. So the particle is entering perpendicular to direction of magnetic field and explore the motion for what values of charge q will the particle follow a closed path.